We're starting to study for your final exam, and in front of you is your test question from the last test. So it says a test has 20 questions worth 100 points. The test consists of true false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? Okay, so we normally had set these up and you define your variable. So we can either use X, Y, we can use maybe T for true, false, and M for multiple choice. It really doesn't matter. I think when I did it, I did T equals number of. So these are the number of true, false questions on the exam. And let M equal the number of multiple choice questions. So now we want to go through, we want to set up our problem. Well, it told us that the test had 20 questions, and then it was also worth 100 points. So if they have 20 questions, we know that the sum of the true, false, the number of true, false questions, plus the number of multiple choice questions has to equal 20. We know that the sum of the points for all the true, false, and the multiple choice was 100 points. And then here it also tells us how much each piece is worth. So true, false questions are worth 3 points. So if we do 3 times T, plus we know that the multiple choice questions are worth 11 points each. So plus 11 M equals 100. So we got our 2 equations and our 2 unknowns. And so you can choose if you want to use the substitution method or the elimination method. I ended up using the elimination method. Let's multiply this first equation by -3 on both sides of our equation. And if we do that, then when we sum it with the other equation, the T will go away. And so if we distribute that -3, we get -3T plus -3M, or I'm just going to write -3M, equals -60. And then adding it to the other equation. So 3T, I'm just going to put the other equation below for now, plus 11M equals 100. And so when we sum these up, we get 8M is equal to 40. And so if I divide both sides by 8, I get the M is equal to 5. So I have 5 multiple choice questions.
Why would that not be 12M?
12M. Because right here I had to multiply. Remember, I had to multiply. I multiplied every single term of that first equation by -3. So -3 plus 8, I'm sorry, plus 11 is 8. If I was just summing it, yeah. If I was just summing the 2 equations without multiplying it by -3, yeah, I would have gotten 12M. We know that there was a total of 20 questions. I'm going to just answer both of them. And so if 5 of them were multiple choice, then I know that 15 are true, false. Okay, so after discussing this, we also talked about doing this, the substitution method, and you guys wanted to see that. So let's solve for T for from our first equation. And so to get T by itself, we would subtract M on both sides. And so we would get T is equal to 20 minus M. And so we're going to go in to our second equation, the one we didn't use, and we're going to plug in this value for T. And so when we do that, we get 3 times t. So I'm going to just put a big parentheses there and I'll go back and replace what t is in a moment. Plus 11m equals 100. And so plugging in what t is, 20 minus m. So now we have one equation with just one variable. So to solve this, we want to distribute our 3, combine like terms, and then isolate our variable. So distributing our 3, we get 3 times 20 is 60, minus 3m plus 11m equals 100. So combining like terms on this left-hand side of the equation, we only have 2 terms that are alike on that left-hand side. That negative 3m plus the 11m, that gives us an 8m. We still have that plus 60 over there on the left, equals 100. So now if we isolate our m, we would first subtract 60. 8m equals, well, 100 minus 60 is 40. And now we would divide both sides by our 8. So 40 divided by 8 gives us 5. And 20 questions, 5 of them are multiple choice. So again, 15 would be true, false. So in front of us is an old math.
So the math final is going to be similar to what we're seeing here.
Okay, so we're looking at an old math 101 final, and we're just going to walk through this. You had a chance to try it, and now we'll see how you did. So order of operations, we go inside the parentheses, most inner parentheses if possible. And so this 8 minus 5 here, let's work on that. And then also, because it's not affecting it, let's work on that 4 minus 2. So when you're doing this, it's important that we bring down everything that we're not working with, because if you don't, then there's a lot of room for error. So we have 24 minus bracket 5 plus. And so now we're looking at 8 minus 5, which gives us 3. Close that bracket. Minus, and then looking at 4 minus 2, that is 2. Think of it as just that 2 has the cubed. It wouldn't matter. We would have gotten the same result because that is an odd number, but it's just kind of important to see. Right here is our next order of operations. We still have a bracket in there. So let's simplify that in there, bringing down our 24. We have 24 minus 5 plus 3. So 5 plus 3, which is 8, minus 2 quantity cubed. Well, 2 times 2 times 2, that is also 8. So order of operations, when all the parentheses exponents are done, multiplication and division left to right, that's not there. So addition and subtraction left to right. So 24 minus 8 is 16. 16 minus 8 gives us 8. Okay, so now we have a rational expression. So we have a fraction. Treat that fraction as division. And we want to treat that numerator as there's a parentheses around it. And we want to treat this denominator like there's a parentheses around it. And so looking at this, on the numerator, we have 3 plus, well, if I square negative 5 times negative 5 is 25, plus 5 times exponents come before multiplication. So 2 squared gives us 4. All over, well, 5 squared in the denominator, that's 25. All times 8 minus 5 inside that parentheses gives us 3. So moving left to right, 3 plus 25, I can combine that 28, but before I combine it here, I need to multiply. Multiplication comes before addition. So 5 times 4, so that's plus 20. All over 25 times 3, which is 75. So 28 plus 20 is 48. All over 75. Let's see if there's anything in common here. And so notice actually 48 and 75 both have a 3 in common. So we want to reduce these as far as possible. And so we're dividing 3 into the numerator and the denominator. So 3 goes into 48 16 times. All over 3 goes into 75, 25 times. So simplified form is 16 over 25. Okay, so first thing we want to do in this next problem, we're simplifying this expression. You must notice that this problem does not have an equal sign in here, so we're not solving for the variable. And we can't do something on one side as we do on the other. So first thing we want to do is distribute. Let's distribute that -8 to both terms. And so -8 times 6r, that's -48r. And -8 times +4, that's -32. Plus, now let's distribute the 4 here. So we have 4 times 10r is 40r. 4 times 4, so plus 16. So now we want to combine like terms. Like terms are the terms that have the same variable and the variables raised the same power. So we have a -48r plus a 40r. Opposite signs, we subtract, keep the sign of the larger number. So -48 or 48 minus 40 is 8. So it's going to be -8r. Looking at -32 plus 16. -32 plus 16, opposite sign, subtract. 32 minus 16 is 16. Larger one is negative, and so it's -16. Okay, so -8r minus 16. And so if you didn't get that, hopefully you saw where you went wrong. And then some of you are starting to put in what you got for the next question into the chat. So if you've done that one, let me know. If not, I'll give you a couple minutes to do it. So the next problem, let's look inside the parentheses. First, work inside the parentheses. I see though we have a 1/2 x minus a 1/2, and those aren't like terms. So we can't combine those. Same sort of problem over here. 1/4 x minus 1/5. They're not like terms, so we can't combine those. So let's distribute the 1/2 in front of the first parentheses. So we have 1/2 times 1/2 x. So multiplying the numerators together, we get 1 all over 2 times 2. So 1/4 x. Distribute 1/2 to the -1/2. So -1/2 times +1/2 is -1/4. Plus, so now let's distribute the 1/3. So 1/3 times 1/4 x, that's 1/12 x, minus 1/3 times -1/5 is -1/15. So combining like terms, notice we need a common denominator. So 1/4 x plus 1/12 x. So the common denominator of those two fractions is 12. And so we can multiply by a fancy one to the 1/4 x to get a denominator of 12. So we have 3/3 times 1/4 x is 1/12 x plus this 1/12 x. I'm just going to write it. And now looking at the constants. So notice the constants, we have a 1/4 or -1/4 minus a 1/15. So we need a common denominator there. So the smallest that they both go into is 60. And so I'm going to multiply this 1/4 by 15 over 15. That's going to be my fancy one. And I'm going to multiply this -115 by 4 over 4. Okay, so -1/4 times 15 over 15 is minus 15 over 60 minus 4 over 60. So combining like terms, 1/12 x.
That first 1/4, when you times it by the 3 over 3, shouldn't it be 3/12?
Thank you. Yes. Thank you for stopping me. Thank you. So that should have been 3/4. I'm sorry, 3/12 x. So 3/12 x plus 1/12 x. So combining those together, 3 plus 1, so that's 4. Keep the denominator the same, 12x. Minus,
And then on the negative 15/60, aren't we supposed to keep the x there?
there was no x when we, oh wait, let's see.
I think that's a plus sign.
Yeah, that's just a plus right there. I just kind of squeezed it in here, right here. Was a plus. So there was no x on that one. Okay. So we have a negative 15/60 minus 4/60. That's minus 19/60. We just want to reduce that 4/12. That's the same thing as 1/3 x minus 19/60. Okay, so listing, we have 14 square root of 8, -5, 0, 0/5, square root of 9, -6/0. And we want to list which ones are natural. So natural numbers are the ones we start naturally counting with 1. So 1, 2, 3, 4, all the way to infinity. And so let's go through and capture any of those. So 14 would be one of those numbers. Square root of 8 is not, -5 is not, 0 is not. 0/5, that's equal to 0. Square root of 9, that is equal to 3. So 3 is a natural number. And -6/0, this is undefined. Can't divide by 0. Integers, those are the ones coming in from negative infinity, -3, -2, -1, 0, 1, 2, 3, following in that pattern. And so we can have the negatives in here and 0. So 14, whoops, I'll go back to whole numbers later. 14, -5, 0. I don't have to list 0 twice. 3 would work. Whole numbers, those are 0, 1, 2, 3. So they're the natural numbers plus 0. So we would have 14, 3, and 0 in there. Rational numbers, those are the ones in the form of P/Q. And so we have 14, -5, 0, and 3. Irrational numbers, those are the ones where the decimal goes on forever but never repeats itself. Square root of 8. And that's the only one. And then real numbers, these are all real numbers except for that one that's undefined. So 14 square root of 8, -5, 0, and 3. So properties, name the properties illustrated by the statement. So we have 6 times 4 times 9. And so notice just the parentheses has moved. And so moving just the parentheses, because it's strictly multiplication, this is the associative property. Of multiplication. The next one we have -5, parentheses 7 plus 9. And then this is equal to -5 times 7 plus -5 times 9. So right there, they're using that distributive property. Eight, we have 6 plus 9 plus 7 equals 9 plus 6 plus 7. So notice that inside this parentheses, we just swapped the order that we were adding, 6 plus 9 and 9 plus 6. So that's the cumulative property. of addition.
Really quickly, what's the difference between associative and commutative property again?
Okay, so associative property is that we're just moving the parentheses. So for instance, if we had like 2 times 3 times 4, this would be the same thing for associative, 2 times 3, and then times 4. So this was associative. Where if we get commutative property, that's where we're changing order. So 2 times 3, we might have rewritten this as 3 times 2 times 4. Actually, let's do it this way. How about commutative property inside that parentheses 3 times 4? We swap the order 4 times 3. So switching the order of 2 numbers is the commutative property. And just rewriting where the parentheses are is the associative property. Just got to make sure that what you're putting down is true. So let's look at problem 10, and it says 1/4 times the quantity x plus 6 is equal to 1/8 times the quantity x plus 8. So we could clear our fractions first by multiplying by our least common denominator. And if I look at my fractions, I have a 1/4 and a 1/8. So my LCD, my least common denominator, would be 8. So because this is an equation, we can do that. And so we're going to multiply this one side by 8 times the other side by 8. So notice 4 goes into 8 twice. So on this left-hand side of the equation, we have 2 all times the quantity x plus 6 is equal to, well, 8 times 1/8, that's just 1. I can put my 1 here if I want, but I don't need it. All times x plus 8. So I can just write it down, x plus 8. So let's distribute our 2 on the left-hand side. So we get 2x plus 12 is equal to x plus 8. So we have x's on both sides of our equation and numbers on both sides. So we want to get the x's to one side. So let's subtract x on both sides. And the constants on the other. So subtract 12 on both sides. So 2x minus x, that's 1x, equals 8 minus 12, which is -4. So x equals -4. So the next problem, we have -3 times the quantity x minus 7, and then close that parentheses, minus 9, equals 2x minus 5 times this quantity x minus 8. So first thing you want to do is we want to distribute and simplify each side of the equation down before we start moving things. So distributing our -3 inside the parentheses, we get -3 times x is -3x. -3 times -7, this gives us plus 21. Let's bring down our minus 9, equals 2x. So be careful here. You want to carry the sign when you're distributing. So let's treat it like a -5. So distributing -5 to each term inside that parentheses, we get minus 5x, and -5 times -8, so plus 40. We can simplify on each side of the equation. So we have -3x. We have 21 minus 9, and that is 12. So plus 12 is equal to, over here we have 2x minus 5x. So that gives us -3x, and then plus 10. So notice if we add 3x to both sides of our
Isn't
equation.
it 40?
It's not
Not
40,
10.
thank you. Yeah, 40. I don't know where I got the 10. If we add 3x to both sides of our equation, we get that those cancel and we get 12 is equal to 40. This is not a true statement. And so there's no solution. Okay, so number 12, we have the problem A equals P plus PRT, and we want to solve for T. And so we want to get the term all by itself that we're looking with the variable that we're trying to solve for. So we have PRT is, so I want to get this P to the other side. So I'm going to subtract P to both sides, is equal to A minus P. Now to get T by itself, I'm just going to divide every single term by PR, or I can just put everything like this over PR. I prefer that actually, because then it's one fraction. So we get T is equal to A minus P all over PR. And so technically how some of you are writing it, you would want to put parentheses around the A minus P, because how you are writing it, just kind of think of the order of operations. If we write A minus P divided by PR, this is just saying that that P is divided by PR and the A is not. Where if we had parentheses around the whole thing, then remember parentheses is saying that's a grouping, that whole group is divided by PR. Okay, so next is everybody's favorite, so those word problems. So it says the code to unlock a safety deposit box is 3 consecutive odd integers whose sum is 105. Find the integers. Okay, so remember consecutive integers were 1, 2, 3, so just adding one to get to the next. Consecutive odd integer, well, let's say if I was starting at an odd number 3 to get to the next odd number 5, I would have to add 2. To get to the next odd integer from 5, I'd have to add 2, I get 7. And so we could say the first odd number is X. Then the second one is X plus 2. And the third odd number, well, I would take the one before. So X plus 2 and then plus 2. And so now let's set up our equation. It says that the sum is 105. So I'm going to take my first integer X, odd integer, plus my second odd integer, which is X plus 2, plus my third odd integer, which notice here is the same thing as X plus 4. So plus X plus 4. Summing all those integers, 3 odd integers, consecutive odd integers, we get back 105. Technically, I don't need those parentheses there, but I just kind of wanted to put them there to distinguish which they're the different odd numbers. So now let's combine like terms. So we have 1x plus another x plus another x. So we have 3x, adding our constants, 2 plus 4, so plus 6. This is equal to 105. So if we subtract 6 on both sides, we get 3x is equal to 99. Divide both sides by 3, we get x is 33. So that's just the first odd integer. So the next one we know is 35, and the next one would be 37. So the 3 consecutive odd integers that sum up to 105 are 33, 35, and 37. So the next problem in front of us says you have taken a gardening for relaxation and have decided to fence in your new rectangular shaped masterpiece. The length of the garden is 12 meters and 30 meters of fencing is required to completely enclose it. What is the width of the garden? Okay, so we know that it's a rectangular shape. And so we have a length, width, and width. The length of the garden is 12 meters. And 30 meters is required for fencing to completely enclose it. So what is the width? Okay. So we know that the perimeter, right, is twice the width plus twice the length, just summing all of the sides. And if we put in 30 in here, we know that the perimeter, because that's how much fencing we need, we're enclosing that garden. We know that that's going to be 30. And we also know that the length is 12 meters. So we can go in here and we can plug in what length is. So doing that, we get 30 is equal to 2W plus 2 times our length, which was 12. So 30 equals 2W plus 2 times 12, which is 24. Subtract 24 on both sides, we get 6 is equal to 2W. Divide by 2, we get W is 3. So the width is equal to 3 meters. So Ming got a 17% in her salary from last year, a raise in her salary from last year. This year, she's earning $119,340. How much did she make last year? So let X, for some reason, just because I'm so used to putting it over here. So let X equal the amount made last year. Her salary last year. She got a 17% raise. And so we're going to look at the amount that she got, X, plus she's 17% of that. So remember, we put our percents in decimal form. So 0.17 of X. And we know that her new amount is 119,340. So combining like terms here, X plus 0.17X. Well, think of this, this is a 1. So think of that as 1.00. And so adding 1 to 0.17 is 1.17X is equal to 119,340. So to get X by itself, we want to divide both sides by 1.17. And so you are allowed a calculator on the final. So plugging that in the calculator, you get $102,000 a year. And not doing pretty bad. She's doing pretty good in her life. Okay, so working through the rest of these questions. The next one we have, solve the compound inequality, graph the solution set. Well, first of all, that's not a compound inequality, but that's okay. Let's subtract 3 on both sides of our inequality. We have negative 3x is less than 9 minus 3 is 6. Now we're going to divide both sides by negative 3. Remember, when we're dividing by a negative or multiplying by a negative, that changes that inequality sign, the direction. So we get x is greater than negative 2. So on the number line, if this was 0, negative 1, negative 2, we would have anything bigger than So have that parentheses there and shaded to the right of it. And then interval notation, we're starting at -2, so parentheses -2, but not including, and going to infinity. So 17, you're evaluating the expression when x equals -2 and when y is equal to 3. So going in and plugging in those values. So we have 3 minus parentheses, 2 minus, and I see that I have an x there. So I'm going to put parentheses where I'm going to rewrite what x is. And x is -2. So remember, a minus and negative is addition. So we have 3 minus. Inside the parentheses, order of operations, we're going to do this first. So this is really 2 plus 2. So we have 3 minus 2 plus 2 is 4. And we have 3 minus 4. This gives us back -1. So part B, we have 12 divided by x times y. So 12 divided by, let's plug in what x is and what y is. So what x is -2, and what y is 3. Order of operations. So this is where it's important. It's telling me I'm dividing 12 by x and then multiplying. And so we get 12 divided by -2. That is -6. And then we're going to multiply it by 3. So this would give us back -18. If we had wanted it to be where we were dividing by that multiple of xy, it would have been written a little differently. It would have been 12 divided by parentheses xy. Then we would know we first multiply our x times our y, and then we'll divide it into 12. So that would have been 12 divided by, well, -2 times 6 is -2 times 3 is -6. And 12 divided by -6 is -2. So order of operations is really important. You can see the difference there. Multiply and divide, and the order it appears left to right. Okay, so the next problem says we have -3x minus 6y equals 12. We want to graph the linear equation by finding and plotting its intercepts. Okay, so recall to find our intercepts, our x-intercept. We know that y is always 0 when we have a point on the x-axis. So we're going to let y equal 0. And so if we do that, we get -3x minus 6 times 0 equals 12. Well, anything times 0 is 0. So we get -3x is equal to 12. Divide both sides by -3, we get x is -4. So we have an x-intercept. Oops, I plotted on the wrong side, is -4. It's right here. So if I wrote it as a point, it would be -4, 0. Our y-intercept, we're going to let x equal 0. And so we have -3 all times 0 minus 6 times y equals 12. So -6y equals 12. Divide both sides by -6. We get y is equal to -2, which is right here. And so plotting it, we get a line that looks like this. And our y-intercept was 0, -2 was the point. So we had seen different ways to graph by just plotting points, by finding our intercepts, which are points, and by putting the things in the form y equals mx plus b. So knowing the slope and the y-intercept and graphing from there. So we're going to stop for the day.